Before going to the types of stresses, we must know what are the types of forces. Based on the types of forces only, we can classify the types of stresses. So previously we have studied about elasticity, elastic limit, what is maybe stress, what is the unit for stress, how to calculate stress. Here, this slide shows uh, the first one is tensile force, the second one is compression, third one is shear, fourth one is bending, and the last one is torsion. The tensile force is nothing but two equal and opposite pulls. For compression, two equal and opposite pushes. Both are opposite in nature. And the shear is, you can take it as if you tear the paper. If you take a piece of paper, and apply force to tear the paper. This is the simple example for your shear. And the bending, if you apply a force on the beams, or if you apply a compression force on the column, it will deflect. We can call it as bending. And the last one is torsion, to equal and opposite rotation, twisting force that will create torsion. So now we are going to see about what are the types of stresses. So based on the condition of load, we can classify the stresses into two types: major, direct stress, and indirect stress. The direct stress can be further classified into tensile stress, compressive stress, and shear stress. So direct stress are purely based on the nature of load. If you apply tensile force, the corresponding stress will be tensile stress. If you apply compressive stress, compressive load, the corresponding stress will be compressive. If you apply a shear force, then the corresponding stress will be shear stress. And if you apply flexural load and twisting forces, then the both are comes under the indirect stress. So bending and torsion can be classified under the indirect stress. So next we are going to see about strain. So as already we have discussed in the previously about elasticity and elastic limit. So up to certain limit only the material regain its original position after removal of external force. Beyond that limit, if you are increasing the load, the material or body will permanently deformed. That deformation is called strain. So deformation due to external force, we can generally call it as strain. So in this diagram, you can see uh, a rod of circular cross section is subjected to a tensile force. Due to tension, the length of the rod will get increased by an amount of del, that is change in length. Then the strain epsilon is equal to change in length. It is the ratio between change in length to the original length. So as a definition, strain can be defined as it is the ratio between change in dimension. We can generally we have to say it as change in dimension. Any dimension, changes in any dimension will refer to strain. So strain can be defined as it is the ratio between change in dimension to the original dimension, and it is denoted as in some cases small e or small e or epsilon. Since the numerator and denominator are about dimensions and the both unit get cancelled, so always you have to keep it in your mind, strain doesn't have any unit. So these are the types of strain. So similar to types of stresses, we can classify strain into tensile strain, compressive strain, shear strain, and importantly, volumetric strain, lateral strain, linear strain. So tensile strain means if you apply a tensile force, the corresponding strain will be tensile strain. If you apply compressive force, the corresponding strain will be compressive strain. If the load is shear force or shear force, then the strain is shear strain. About volumetric strain, it is the ratio between change in volume to the original volume. Because if your dimensions get changed because of the external force, proportionally the area and other dimension, that volume will get also changed. And about lateral and linear strain, it purely depends on the direction of force. If the strain occurs along the direction of force, that strain is called a linear strain. Strain occurs perpendicular to the direction of force is called lateral strain.